Kia ora koutou. I'm going to do a recap on Simpson's rule for everyone because in our Saturday class yesterday it was amazing how many of you had completely ignored it when you were doing your level 3 preparation. So the reason I'm doing this is that there's a really nice question from back in 2009 that I'm going to video shortly, which is this one here, where we have to use Simpson's rule to do some stuff. So we need to be confident with Simpson's rule, so we're not doing it for the first time desperately relying on the formula sheet. Okay, so Simpson's rule is one of 2 numerical integration techniques that we do in level 3 integration. And in real life, we use it when we're integrating a function that we can't integrate easily. I'm going to show you how it works using a function that we can integrate quite easily. So this is the graph here of y is equal to root x. And we can pretty easily at level 3 find the area under that curve. And so we can get an exact answer. For example, if I wanted to find the integral, the area under the curve here, then we proceed like this. Let me just turn off into shape. Okay, so here's x to the power of a half dx, and off we go. We get 2/3 x to the 3 over 2, evaluated at 2 and 0. And when we work that through, we get 2/3 of root 8, which is 1.886. Okay, so just imagine that we had forgotten how to do all of that. Simpson's rule is going to give me a way to get a pretty decent approximation in a lot of situations. So Simpson's rule will give you a better approximation than the trapezium rule, but it's slightly more complicated. But the trapezium rule divides things up into strips, so does Simpson's rule. So when we do Simpson's rule, the formula that we use is this one here. It's h over 3 times y0 plus yn plus 4 times this sequence plus 2 times the even numbered values. And if you haven't done an example of this, I think this can look pretty confusing, even though it's actually quite easy. So things to notice for Simpson's rule is that we must have an even number of intervals. And that means we're going to be substituting in an odd number of y values. And that's because we have the 2 endpoints, which are y0 and yn. So in this example here, if I told you to find an approximation to that same integral using Simpson's rule, and I said to use 4 intervals, we would divide the curve up as follows. So if we just grab the ruler, 4 intervals between 0 and 2 means that we're going to have gaps like this. You do not have to do this when you're doing a Simpson's rule question, but I think it's worth just seeing it once so that you really do confidently know how to use the approximation. So we're going to be evaluating the height at each of these points, right? So this x value is going to generate y0, and this one is going to generate yn. This is going to be y1, y2, y3. These are odd numbered values, so the y values are going to get multiplied by 4. This is an even numbered value, so it's going to get multiplied by 2. Now the proof of this is cool, and the reason it's a better approximation than the trapezium rule is that it's fitting like a little quadratic between the different points, right? And we end up with this nice summary. So in here, h is the width of the interval, and so that's going to be the total distance divided by the number of intervals. So in this case, it's going to be 2 over 4, which is 0.5. And so now we're ready to go after we've found the y values out. And it's usually easiest to do this in a table. If you've got the big New Lake book, I remember from a few years back that they do this really well with kind of showing you which ones are going to be times by 4 and which ones are going to be times by 2. Okay, so you can do this quickly using your graphics calculator in the exam to get these values. So I did these before I made the video in Excel. Right, so we're just substituting in, whoops, that's 4142, substituting into root x is equal to y. Right, so that's giving me the heights here, 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 here and here. That's a terrible line, never mind. Okay, so now we're good to go. So Simpson's rule will give me an area of roughly 1/2, that's the width, divided by 3 of the two endpoints, plus 4 times the odd numbered values, and 2 times the even ones. And when you bung that in your calculator, you get out an answer of 1.857. Now, if you want to work out the percentage error, just like we did back in year 9, remember that the exact value here was this one. And so the error is going to be, well, the difference between these two, which is, what difference was that? I can't remember, and I want to keep this video really short, but if you figure it out, even with only 4 intervals, the error is 1.5%. So it gives often a really good approximation. So that's all I'm going to do in this video. I'm also doing this because I know tomorrow is the level 3 exam, and this does come up in level 3, and you probably shouldn't ignore it if it does pop up, especially if it's popped in there with a harder problem. So now I'm going to record this, and then I'm going to straight away do the more abstract question, which is this one from the 2009 paper. So you might like to just have a go at that before I do this video, because you have to be confident with how to apply the formula to make it work.